Alright guys, let's move on to the next thing. We've got two instances of subclasses of match many base, and that is match alternate, which is going to let us do alternation, and match list, which will buy us things like any consecutive list of things. You know, so like the gray, for example, GR, A or E, Y, that kind of thing. We could do this kind of stuff so far. This is actually the only two types of tokens that are going to be based off of this match many base. Everything else is going to be based off of match single. So the other kind of operations that you'll see very frequently are going to be things like this. So let's say I have a token, like a literal character, and I want to repeat it one-to-many times. Or I have a different character and I want it 0 or 1 time, etc., etc. So these are variable length. Well, this one, yeah, these are variable length. But the first step on the way there, because these get complicated because this is actually consume one-to-many A's greedily, and that would be lazily, and this would be atomic. So before, as a step that we're going to take before we get there, we're going to do this case, right? I want to repeat this token some number of times. And this will be simple because you either repeat it that many times or you don't. And it's going to bear a lot of resemblance to match list, except that instead of iterating through this list, it's always the same item that exact number of times. So let's set up a new base class over here. And it's going to be called MatchSingleBase. And it's going to implement iMatch abstractly. Abstract class MatchSingleBase, like that. And it will have a public read-only match item. iMatch match item. And the constructor will take an iMatch match item and save it off. Okay, so there's my base class, and this thing, we're going to use this as a base class, or the ultimate base class of pretty much everything else that we're going to do. So let's get down to business and start using it. So the first thing is going to be to build this MatchRepeat. Now, MatchRepeat, like I mentioned, is going to be the thing that takes a single token and runs it as many times as possible. Okay. So I'm going to do something that's going to seem a little non-obvious, but it'll come together later, I promise. So let's add one called MatchRepeat, and I'll go ahead and start closing some of these guys. I'll plop you over here. In fact, I'll give us a little more space. So let's say, okay, MatchRepeat implements, or I'm sorry, is a subclass of MatchSingleBase. And we will need to implement the class, and we will need to generate a constructor. And I never like the formatting because I don't think I need any additional behavior. Oh no! I do need additional behavior. How about that? Okay, so there goes all that formatting it did for me. So an iMatch match item is going to come in, and the number of times we need it to match. So int count. So call the base class with match items, so that'll save that guy off, and then we will have the following, which will seem a little bizarre. So we have the public int, well, how should I do this? Okay, we'll do it this way. Public read only int min. And what I'm going to do is set min equal to count. Now, why would I call it min? Well, that will be clear later. An alternative will be to simply have a helper one called public int count, which is just going to map to min. Okay, so you can refer, if you have an instance of this, you can refer to either the count or the min and you'll get the same number. But why it's called min will become clear later. Okay, so just like every other thing, and more specifically just like match list, and this is really kind of the nice thing about this, is we already have the code, right? Match list does exactly what we want, except it iterates through the list instead of repeating the same one that many times. So one way to think about MatchRepeat is it's just match list with the same token some number of times, right? That's just the length of the list. So the logic is going to look very similar. To that end, I'm going to go ahead and jump to this and say public bool match forward. And this will be a match context, and a defaulting index integer set to 0. And this guy, we can also go ahead and just say it's going to return match forward with this context at the default 0. Okay, and the reasons are the exact same reasons as over here. So what does match forward do? Well, match forward does exactly what it does over here, except you replace this with match item, right? Well, that's exactly what makes sense. So while the index is less than min, and I'll use min here, then if match item matches in this context, then we will increment the index, right? And carry on. If not, then what we need to do is go back an index, right? So we've matched the index minus one, and we've now failed to match, so we need to go back to the previous time that we matched it and see if there are alternatives. And once again, we'll structure it the same way. So while index is greater than or equal to 0, and we're not getting more hits out of our match item, match item dot match next in the context, let's decrement our index until one of two things happens. Either I go negative with this index variable, which means I've backtracked all the way and failed. So if index is less than 0, then we can just return false. Otherwise, we will increment the index plus plus. And then that will leave and we'll let the loop continue just like it does over there. And just like over here, if you make it all the way out of the while loop, then we've succeeded. Okay, so great. Similarly, let me zoom back out a little bit. Similarly, for match next, it's going to behave, identically to match next over here. So what we'll do is this. So we'll say int index equals min minus 1, right? Where in this case it was the length of the thing minus 1. In this case it's min minus 1. That's the minimum number of times we have to match it. And literally it's the same exact code, right? So while the index is non-negative and we can't match item dot match next in this context, we need to, whoops, it's got all weird, and not match item dot match next context. Let's decrement the index. And just like before, we could have failed, so we can check for that right now. If I fell off the end, off the front, then we're done. Out of luck. If we have not done that, then that means that there was an alternative that occurred during one of our repetitions of our match item, and we can now return match forward from our current location. So in this context, well, not current location, but from the next index, right? And it will continue from there. That's MatchRepeat. So let's flip over here and say public static void MatchRepeat test1, and we'll have var context equals new match context, and we'll match the string. I don't know, we'll just do A's for now. And we'll have var char A equals new match char of A. And we will have var rep equals new match repeat. And we will give it the match item char A. And we'll say you have to match 3 times. Okay? And then we will exec test on rep on this context, and we'll just see what happens. So now let's call match repeat test1. See what happens. Okay. So it matched 1, 2, 3 times, and then we were done with our 3, and then match next failed because there's nothing to go back to. Okay, so now let's poke around with this guy in the test a little bit differently. So could I match 4 times? Well, yeah, I would expect it to match everything, and then it unrolls. Can I match 5 times? I certainly hope not, right? Runs to the end, and at the next index, the match char fails a match, and then it backtracks and nothing else can possibly match, so that's dead. Can I match 0 many times? Sure, no problem. Okay. So this appears to be doing what we like. The one thing that's, again, hard about this is to show that the backtracking is, doing what we think it should be doing. So I like to do it this way. So let's make that 3. And I will do var list of 2A's equals new match list of a new array of these guys, and we will have char A, right? And then I will have var alt equals new match alternate of, new iMatch array that will be char A and list of 2A's. And it will look something like that. And then we will repeat the alternate. Twice? Oh, let's try that. So first of all, what did I construct here? So I have the character, I have a list of, so this is a string AA, I have a single A, I have an alternate with that and then that, so I have A or AA, and this is going to be repeated twice, right? So I take the whole thing and I repeat it twice right there. So this is interesting because I should be able to match A, right? And then I'll push state 0 because that's the first option. Then I'll rematch this alternate token again and I'll match the A. And I expect to be out to here. And then that will work. And then I'll say match next to go through the next permutation. It'll backtrack and it'll pop off one of the items on the stack and get back to here and say, well, I have an alternate I can try, and that'll be AA. And that should match those two then. And then our stack should say 0, 1, and we will have matched everything. And then we will match next will run again, and this will be out of alternatives, and then we'll roll back into the first one, which will pop the 0 off the stack, or I'm sorry, yeah, it'll pop the 0 off the stack, and ask, does it have an alternative? And it'll say, yes, I have AA. So then the first alternation will match those two, then the repeat will push us into the second iteration of this, and it'll ask it, do you match? And it says yes, because there's an A there. The next one, though, will fail because it'll backtrack into the alternation. It'll say, yeah, I have one other option, let's try it. And this AA sequence will fail because that will push it off the end of the string. So that fails completely, so we roll back to the previous one and say, do you have other options? And it backtracks and then says no, and then everything gets collapsed to the end. So I don't know if that's really helpful or it's better just to look at it. Okay. So here you go. We match successfully, right? And the stack is 0, 0. So the alternate right here picked the first one and then the first one again, and we've consumed 2 characters. We call match next again on it, and it backtracks into this alternation, right? And then it opts to take AA like that. And that works out, so that's what we expected. We match next again as though we've been backtracked into again. And this one was out of options, so that popped off, and they went all the way back to that first match, right? This guy 0. And it actually had a valid second match, which was 2 characters. And then this guy matched again in the first entry. And then, like we said, if I say match next again, the second entry was 2 A's long, which is too long, so it failed. Everything else failed, and we were out of options. And most importantly, the stack and the pointer are reset to exactly where they should be. Okay? And that's what I want to see. I want to see that the state is all restored. So that's repetition. Okay? And we'll get into some more interesting tests of this in the future.